Assalamualaikum. My name is Muhammad Zulwaka bin Makzin, matrix number A210141. Today, I will present a study titled Assessment of Carbon Sequestration by Mangrove Plantation in Casamance, Senegal, conducted by Bernard Alois B. Manga and colleague, and it was published in 2022. This study evaluates how restored mangrove plantation contribute to carbon storage and climate change mitigation in southern Senegal. Before discussing the study, it is important to understand what is carbon sequestration. Carbon sequestration is a process of capturing the storing carbon dioxide, which is CO2, from the atmosphere to reduce greenhouse gases and slow down global warming. Plant absorbs carbon dioxide through photosynthesis and store carbon in leaf, stem and trunk, roots, and also sometimes in the soil for a long period. Mangrove ecosystems are particularly important because they can store much more carbon than many terrestrial forests. This carbon stored in coastal ecosystem is often called blue carbon. Therefore, protecting and restoring mangrove is considered an effective strategy for combating climate change. Mangrove in Casamance region of Senegal provide many benefits such as fish habitat, wood resource, coastal protection, and also support local livelihood such as fishing and also oyster harvesting. However, mangrove area in Casamance decreased dramatically from 500,000 hectares in early 80,000 to 83 hectares in 2006 due to drought, salination, excessive wood harvesting, and also human activity. To restore this ecosystem, the Organization of Ocean Ecosystem began large-scale mangrove plantation campaign in 2006. Despite the restoration effort, the carbon sequestration potential for this plantation had never been scientifically evaluated from this study. The study had two main objectives, which is first, to estimate the amount of biomass produced by the mangrove plantation, and also to determine how much carbon this plantation are capable of storing. The researcher also aimed to create a model that could predict carbon storage using simple tree measurements such as height and stem circumference. The research was conducted in a department of Osseye in southern Senegal. The three sites were selected was Akward, Mlom, and also Diambering. A researcher examined 24 mangrove plantations distributed among 8 villages. They established some sampling plot measuring 2.5 by 2.5 meters and collected measurement of plant height, stem diameter, crown size, survival rate, and also biomass of the leaf, stem, and also the root. Then the sample were dried in oven to determine the dry biomass and then converted to carbon stock using the standard conversion factor of 0.47, meaning that approximately 47% of dry mass is carbon. The study found that the mangrove roots contain the largest proportion of biomass. Average dry biomass value was 0.331 ton per hectare in stem, 0.828 ton per hectare in leaf, and 1.66 ton per hectare in roots. This indicates that the root system are the major carbon component in mangrove ecosystem. Among the three sites, Akward produced the highest biomass due to its muddy soil and favorable environmental condition. The total amount of carbon stored by the plantation was estimated at 0.55 ton of carbon per hectare in stem, 0.389 ton of carbon per hectare in leaf, and 0.501 ton of carbon per hectare in roots. This gives a total carbon stock of approximately 1.46 ton of carbon per hectare. Again, roots store the largest amount of carbon, accounting for almost half of the total carbon stock. Among the site, Aquat store 0.921 ton carbon per hectare, and the rest, which is this difference, were mainly related to soil quality and also site condition. The researcher developed mathematical model to predict carbon sequestration. The strongest relationship was found between plant height and also carbon storage. The model achieved a coefficient of determination of 0.81. This means that 81% of the variation in carbon stock can be explained simply by measuring plant height. This is useful because measuring tree height is easier and cheaper than harvesting tree to measure biomass directly. This study demonstrates that restored mangrove plantation can act as significant carbon sink, support climate change mitigation, restore biodiversity, protect coastline from erosion, support local livelihood and fisheries. This finding also highlight that young mangrove plantation can rapidly accumulate carbon and contribute to future carbon market and environmental conservation program. To conclude, mangrove restoration in Casaman has successfully increased biomass production and also carbon storage. The plantation store approximately 1.086 ton of carbon per hectare. Roots were the largest carbon storage compartment, and the plant height proved to be an effective predictor of carbon stock. Therefore, mangrove restoration should be promoted not only for biodiversity conservation but also as powerful tool for climate change mitigation. Thank you for your attention.